Today's lesson is on the quadratic formula, and what this allows us to do is solving for x, finding those intercepts, those roots, those zeros, those solutions without factoring, and it's actually a formula. There are some requirements though here, and one is that you recall how to simplify radicals from last year, because I know you did this. So just for review quickly, the square root of 24, the perfect square numbers are 1, 4, 9, 16, 25, 36, 49. All we're doing is squaring 8, 9, 10, 11, 12, 13, 14, 15, etc. Okay, so what we're doing is looking for these numbers that divide evenly into 24, and it just so happens that it's 4 and 6. So that's 2 radical 6. This is how I taught it. You may have been taught a different way. 44 would be 4 and 11, so that's 2 radical 11. 27 is 9 times 3. That's 3 radical 3. So just remember, this would be 25 times 3 radical 3, which is 5 radical 3. So we'll see if you remember as we go through here. But the quadratic formula is rather complex and rather easy. So the formula, which I encourage you to write down every time, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Many students regretfully forget that 2a is underneath the negative b as well. So please be aware of that. That's very important that we don't lose that. Now the discriminant is the square root part. That's this, the b squared minus 4ac, and that tells us how many solutions. Tells how many solutions, meaning that tells us if the parabola is going to go through 2 places, 1 place, or no places, like that. So if b squared minus 4ac is greater than 0, it's going to be 2. If b squared minus 4ac is equal to 0, it's going to be 1. And if b squared minus 4ac is negative or less than 0, then it doesn't have a solution. They're imaginary solutions, which we don't know what those are yet. Okay, now where does this a, b, and c come from? Well, simply this. Remember, ax squared plus bx plus c was standard form? Well, that's where they come from. Those are literally the numbers. So a is 2, b is negative 4, and c is negative 6 in number 1. We're supposed to find the discriminant, that's these, and tell how many solutions we have. Okay, so that's b squared minus 4ac. That's negative 4 quantity squared minus 4 times 2 times negative 6. Now you can take a calculator or see that that's going to be, what, 48? 16 plus 48, which is 64. Hey, that's positive. 2 solutions. Okay? Now this one is a problem. It's not in standard form. So what do we have to do? Right, we need to subtract 4x and then write it in standard form. There we go. 3x squared minus 4x plus 16. So a is 3. Oops, sorry. A is 3, b is negative 4, c is positive 16. So b squared minus 4ac, is 16 minus 12 times 16. Now, I don't even care what that number is, but I can tell it's going to be negative. So that has 0 solutions. 0 real solutions. Okay? So, I didn't summarize this. 2 solutions. two real solutions, one real solution, and 0 real solutions. There we go. I apologize. Okay, now on the last one, b is negative 12 squared minus 4ac. That's 144 minus, that's 144, that's 0. So it has one real solution. So the discriminant, the b squared minus 4ac, tells us, and I don't need the square root, sorry, how many solutions we have. Now on these four, though, we're going to actually find the answers to those solutions. So some of these might be factorable too, but this is something that always works. The formula. The formula is negative b plus or minus the square root of the discriminant all over 2a. Now be careful when you substitute. Use parentheses. It's very important. All I'm doing is substituting in the numbers. 2 times 1. Okay, so that's going to be negative 4 plus or minus the square root of 16 minus 24, over 2. That's negative 4 plus or minus the square root of negative 8. How many solutions, guys? No real solutions. So this thing is unfactorable and unsolvable in the real number system. Later on this year, we will talk about that. We will talk about this radical negative. We can't take square root of a negative. It doesn't work. Okay, 2, well, we got to set it equal to 0. We got to get it in standard form. So we subtract 10 and 2n. That leaves us with 3n squared minus 10n plus 5 equals 0. Now we can attack this. A is 3, B is negative 10, C is 5. So it's n equal now. Same formula. Negative b, yes, negative 10 is going to be positive, but I'm going to write it negative 10. Negative 10 squared minus 4 times 3 times 5 all over 2 times 3. Oh, this could be ugly. So 10 plus or minus 100 minus, is that 60? All over 6, which is 10 plus or minus the square root of 40 over 6. Now, you could put that in your calculator. That plus or minus means 10 plus radical 40 divided by 6 and 10 minus 40, radical 40 over 6. So let's break down square root of 40 first. I think that's 4 and 10, isn't it? So that's 2 radical 10. So this would be 10 plus or minus 2 radical 10 all over 6. And if we're going to keep it real, and I'm not going to use my calculator, all I'm going to do is divide by 2. So 5 plus or minus radical 6 all over 3 is our answer, because 2 goes in there 3 times, 5 times, and 1 time. So 5 radical, that shouldn't be 6, should it? Sorry, that's a 10. 5 radical 10 all over 3. Now, if you want to put that in your calculator, that'd be 5 plus square root of 10 divided by 3, 2.72, and then 5 minus radical 10 divided by 3. So 0.6125 and 2.72 would be the two answers in decimals. Number 3, again, you've got to set it equal to 0. That's the only way the 0 product property or this equation will work. So we subtract x squared and we subtract 4. So A is 1, B is negative 8, and C is 16. So again, we use this formula. X equals negative negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 16 all over 2 times 1. Let's see what that gives us. Let's see, 16 times 4, hey, that's 64 all over 2. Well, that's 0, isn't it? Well, the square root of 0 is 0, so this is just simply 8 divided by 2, which is 4. So x equals 4. So those are our solutions. Now number 4, a is 2, b is negative 5, c is 3. Plug it in the formula and see what you come up with.